Okay, I'm going to go through in detail how to graph a piecewise function, evaluate a piecewise function, and write a piecewise function. So I'm going to go over homework number 6 in detail, and hopefully this will help people who are having any difficulties with these. So the first one, you can see that there's 2 equations, there's 2 pieces. So I'm going to start with the top one. Y equals negative 3x plus 1, and we talked about how we want to be using a pencil because we'll probably be erasing some of these dots as we go through this process. So negative 3x plus 1, we know the y-intercept is 1, starting the y-axis. The slope is negative 3 over 1. So from that point, I'm going to go down 3 to the right 1, down 3 to the right 1. I'm also going to reverse that and go up 3 to the left 1, up 3 to the left 1. These are all the points that fit on my graph paper for that first equation. Now, typically we're going to use only part of this full graph, so a piece of this graph. And the if part tells us which part of the graph we're working with. It says if x is less than or equal to 1. So I know that I'm going to have an open circle, a closed circle at 1. And less than or equal to would be graphing to the left. So I'm going to find my x value of 1. I'm going to find the point that refers to from the dots I created, which I've just highlighted. And I'm going to make that a little bit bigger of a dot. That's going to be kind of my starting point here. Now from here, I want to follow my points to the left, the dots that I already have. So to follow to the left means I'm going upward and to the left. I'm going to put an arrow at the end. I'm going to go back. I'm going to erase any points to the right of 1. So this point down towards the bottom, I'm going to erase that. And this is my first piece. All right, so now we'll move on to the second piece. Y is equal to x minus 2 if x is greater than 1. So x greater than 1, that means at 1 I'm going to have an open circle, and greater than is to the right. So let me get all the points that I'm going to be using for this second equation. I'm going to do this one in red. The y-intercept is negative 2, and I would suggest using light dots because we know we're going to erase some of these dots. Now the slope of this line is 1, which means 1 over 1. So I'm going to go up 1 to the right 1. You'll see all these little red dots I'm putting here. If I continue the dots going the other direction, I'm going to go down 1 to the left 1. Now, some of you may be looking at this and you already recognize we're not going to use all those dots on the left because these are, by definition, functions. This is a piecewise function. And it must pass the vertical line test. So those dots on the left-hand side, probably not going to be used. If you had a vertical line going through, if this red line was going off to the left, that green vertical line would hit the blue and the red at the same time. This would not be a function. So if you start to get to the point where you know certain dots are not going to be used and you want to save a little time, that's absolutely okay. But for the time being, I'm going to put all those dots and then erase ones I don't need later on. So an x value of 1, or to the right of 1. So here's my x value of 1. I'm going to find the dot that refers to, which I've just highlighted there. I need to make that an open circle. So I'm going to erase it. I want to make sure it's clearly an open circle right here. That's my starting point. Now I do know that I'm going to the right. So I'm going to start at that open circle, follow the dots that I have to the right. If I do that, I'm going upward to the right this time. Any dots that are to the left of an x value of 1, I'm going to erase. So I'm going to erase those as you see. And this is what my graph looks like. You guys can see that this does pass the vertical line test. If I put this green vertical line and I take this and I slide it left, slide it right, it's never touching your graph at more than one spot. Even at x equals 1, the open circle above the closed circle is okay. You just do not want to have a closed circle on top of a previous closed circle. All right, so we're done with the first graph. For the evaluating part, what you're given is an x coordinate, an x value of 0 here. And so we're going to look at the if part. And for my 2 equations, this tells me I should use the top equation if x is less than or equal to 1, and I should use the bottom equation if x is greater than 1. So my x value of 0 is less than or equal to 1. I'm going to use the top equation here. So I'm going to plug in where I see the x value. This is negative 3x plus 1, so I'm going to put a 0 in where the x value was. And that's going to give me negative 3 times 0 is 0 plus 1, and that just gives me 1. So f of 0 is equal to 1. All right, for f of 5, again, look at your x value. The x value is 5. If my x value is less than or equal to 1, I'll use the top equation. If my x value is greater than 1, I'll use the bottom equation. And 5 is greater than 1. So I'm going to plug 5 into the bottom equation, the x minus 2, and put a 5 where the x used to be. Subtract those, and we get 3. That's all we have to do. At the end, don't write any inequality after this. This, what you're finding right here, the 1 and the 3 that we found, those are y values. Don't put them into the x less than or equal to 1 or the x greater than 1 inequalities. These are y values, not x values. All right, so that's the first one. I'll go through the second one as well. Start with that top equation. Y equals 1/2 x minus 2. So I'm going to go to negative 2, put a dot there for my y-intercept. Slope is up 1 to the right by 2, positive slope. I'm going to put all the dots that I can fit onto my graph paper on here. I don't know at this point which ones I'm using. So x is less than or equal to negative 2. So I'm going to have a closed circle at negative 2, and less than is to the left. So I'm going to find my x value of negative 2. I'm going to find the dot that I have that has an x value of negative 2, which I've highlighted. And I'm going to make that a closed circle. It already is, but I'm going to make it a little bit more significant here. And I'm going to follow my dots to the left, which means in this case down and to the left, and put an arrow at the end. I'm going to go back and erase all those extra dots that I don't need anymore. And there's my first piece. Middle piece, the equation is y equals 3 if x is between negative 2 and 4. So negative 2 is going to be an open circle, and 4 is going to be a closed circle. And I'm just going to draw a line between those two values. The equation y equals 3 is a horizontal line. So y equals 3, horizontal line. I'll put all these dots to the left, all these dots over to the right. And I'm going to use this horizontal line between negative 2 and 4. So again, find your x value of negative 2, find your x value of 4, find those dots, and make sure they're open or closed depending on what you need here. So on the left side, that was at negative 2, that was an open circle, and on the right side, this was a closed circle. I'm going to connect those. I'm going to erase what's on the outside, on the left, outside on the right, and get rid of that little dot that's inside the open circle. I'm going to get rid of that too. That should be a clearly open circle without a little dot inside it. Looks like this. That's the middle piece, and then the last piece, I'll do this one in red. Y equals x minus 1 if x is greater than 4. So the y-intercept is negative 1. And the slope of this line is 1, so up 1 to the right 1. I could go down 1 to the left 1. I'm pretty sure I'm not going to be using these points because they would be above, they would be below other parts of my graph, like the green and the blue line. So right away you'd see if I went towards the left from my y-intercept, I would be below previous lines. They would not, the whole graph in total would not pass the vertical line test. So again, if you know you don't need those points, you don't need to put those dots there. For this one, we're starting at an x value of 4 with an open circle, and greater than means we're going to the right. So I'm going to find an x value of 4, find the red dot that that refers to, and that's going to be an open circle. Now, it happens to be where the green circle is closed. So basically, the closed circle fills in the open circle. we're not going to be able to tell the difference with pencil, that there's any difference between a regular dot right there. All right, so I'm starting at that point. I'm going to the right, which means I followed my dots up to the right, put an arrow at the end, erase the dots on the other side, if you put those there. And our graph looks like this. This passes the vertical line test. It's okay for a closed circle to fill in an open circle, which is what we have going on right here. What you should not have a closed circle with this kind of halo around the outside. We don't want that. We want that closed circle to fully fill in the open circle. Okay, so no halo around a closed circle. But this is your graph. Again, you can take a vertical line and just slide it left and right and make sure it doesn't touch any part of your graph more than once. So this passes the vertical line test. All right, for the evaluating, again, we have 3 different equations. We want to decide, are we plugging into the top equation? Are we going to plug into the middle equation? Or are we going to plug into the bottom equation based on the if part of these equations? So for the first one, f of 0, my x value is 0. If my x value is less than or equal to -2, I'll use the top. If it's between -2 and 4, I'll use the middle. And if it's greater than 4, I'll use the bottom. So 0 is between -2 and 4, which is the middle equation. And I'm going to plug in there. Now this equation is just y equals 3. There's no x value to plug in for. So f of 0 is just going to be the 3, and then we're done. For the next one, f of 5. So your x value is 5. 5 is greater than 4. That means I'm going to use the bottom equation, which is x minus 1. I'm going to put the 5 in where the x was and subtract. I'm going to end up with 4. Last one, x value is -8. That's going to go into the top equation. If x is less than or equal to -2, which -8 is, I'm going to plug into that top equation. And if I plug into that top equation, 1/2 x minus 2, 1/2 times -8 minus 2. I just need to simplify this. Half of -8 is -4. -4 minus 2 is going to give us -6 here. All right. So we've done the evaluating and the graphing. The last thing to do is to work backwards, which is what you see in example 3. So typically you'll work from left to right. So I'll do this first equation on the left side with the arrow on the left. I'm going to write out what the equation of this line is. And I need to figure out what the slope is and what the y-intercept is. So find some points that this graph goes through. We're going down by 1. To the right by 2, so the slope is -1/2 x. And then the y-intercept, you can see right here, I highlighted it in yellow, is +3, so +3. We're going to take the right side of this, and we are going to write the -1/2 x plus 3. Now, the if part is going to deal with the x values. So the x values are starting at 4, and we're going to the right. So this will be x is less than or equal to 4 because it's a closed circle. And then the last piece here, last part of this whole thing, I'll do this one in red. The equation of this line is y equals, if you extended it, it would be y equals 5. We'll take the right-hand side, which is just the 5, comma, if. And we're starting at an x value of 4 again for this one, but we're going to the right of 4, and it's an open circle, so x is greater than 4. All right, we've done all two pieces there, so we're finished. Hope that this helps you guys out, and let us know if you